Hello and welcome to the third and final day of ICCE 2016. We've had the morning keynotes just now, and here joining me is Ariel Garten from InterXon, and her company is famous for the Muse head wearable device for measuring brainwaves. She's going to talk more about that in a moment. First of all, Ariel, welcome. Could you tell us about brain-computer interfaces and which ones you think are most suitable for consumer electronic devices?
Sure. So in this morning's presentation, I walked you through a variety of different kinds of brain-computer interfaces. You can do BCI in an MRI machine. That's obviously a large investment. There you're looking at hemodynamic response and being able to trigger an outcome based on change in blood flow to a particular region. The most famous example is out of technology, or an example called Brain Pong in 2004, where two people in an MRI could literally play Pong with their brains. There's a smaller version of it called functional near-infrared spectroscopy, FNIRS, that does very local brain flow or blood flow, very local hemodynamic response. And there you're looking at something that works for very slow BCI interactions because the time course of the blood oxygen response is about 5 seconds. You can also do stimulation technologies. So transcranial direct current stimulation is something that we're beginning to see actually even from a consumer perspective. And then transcranial magnetic stimulation is firmly a clinical application, but we are seeing actually quite good results in the depression spheres, for example. Probably the most robust and ready for the market is using EEG, non-invasive sensors that track your brainwave activity to do brain-computer interface.
Okay, brilliant, thanks. Could you tell us what the difference is between active and passive brain-computer interface?
So there's two different things that we can refer to as active and passive. One is the sensors. So an active EEG sensor versus a passive EEG sensor is one that's able to have sort of electrical amplification on the signal. So that you get better brain state. In my talk today, the difference between active and passive that I was referring to was the kind of brain-computer interface that you're doing. So an active one is one in which you are controlling the system. You are actively trying to control an output. We're at the stage where these kinds of controls are still quite basic. There's a new concept that came up in 2010 by Thurston Zander et al. Around the passive BCI, a BCI that just tracks you as you go and then makes its own decisions so that it can start to change an environment around you, for example. So the example that I gave was the responsive room that we built, and there the elements of the room respond to your brain state. So as you read, the lights get brighter. As you relax, the music dims. As you fall asleep, the blinds close.
Mm-hmm. So the brain-computer interface is the way in which some intelligent system can understand your mood and adapt the world around you to fit your needs without you having to manually do this yourself.
Yeah, so that's actually where we're hopefully going with the sphere of brain-computer interface. So control is one way of interacting with technology, but it's really quite basic. It's really quite binary. What we're seeing is technologies that understand us and respond to us and adapt and build relationship to us. You know, your phone, for example, as you tilt your hand, the screen turns off so that you don't accidentally dial it with your cheek. You know, these are small gestures that we make that allow technology to understand us, which allows a change in technology, which allows us to then exhibit another behavior and interact with it more effectively.
I understand. So the BCI devices are just another way of getting this, of getting data that could be used to make our lives richer. Now, it's time for a commercial break. Ariel, could you please tell us about the Muse? What is it?
Sure. Well, this is Muse, the brain sensing headband. It is a clinical grade EEG in this beautiful slim little form factor. It's 4 channels, 2 sensors frontal, 2 sensors temporal, tracks brain activity in real time, and then sends that to your smartphone or your tablet. And then from there, a wide variety of different kinds of interactions are available.
Right. Now, this has won a lot of prizes, and we're here at CES. Well, in Las Vegas, we just had the Consumer Electronics Show. Some people walking around the show floor might have been tempted to look at wearable devices and say they're gimmicky, or they're superfluous, or they're just something you might get for Christmas and use for a week. But you gave some examples of how the Muse and other devices can actually have serious ways of improving our lives that go beyond gimmicky, and you use meditation as an example. Could you say a few words about that?
Sure. So meditation is one of the applications that we've built with Muse, and it's actually the main commercial use case right now. And meditation has been demonstrated in over 1,000 published studies to be able to improve your attention, decrease your stress, manage your pain, potentially even stave off cancer, and on and on and on. So with Muse, what we do is we make the process of meditation easy. So meditation has all of these benefits, but most people never access them because meditation seems strange, it's hard to do, and you don't know what's going on in your mind. So Muse makes that process simple by giving you real-time feedback on your meditation. You can actually hear what your brain sounds like. So when you're thinking, distracted, ruminating, you hear it is windy, and as it guides you to a state of clear, focused attention, it quiets those winds. So it really takes the guesswork out of meditation and makes the process actionable and tangible. You get real-time feedback throughout, and then at the end you're actually able to see your brain data, see what your brain was doing at every moment in that experience.
And where do I see that, see what my brain is doing?
On your smartphone or tablet. It's just a very simple interaction between you and your device.
Okay, that sounds excellent. What is the magic in Muse? Why is it so special compared with, what are the technical innovations that make it unique?
There are a lot of technical innovations in Muse. So one is the proprietary sensors. These are our own conductive ink sensors and conductive rubber. The other is the form factor, getting something into this slim, easy-to-use form factor that fits on every single head with great signal quality, with dry sensor, literally clinical-grade signal quality compared to a gel electrode system in a dry system that you can buy at a Best Buy for $2.99. And then really important is our algorithms. So we've been able to create algorithms that very sensitively and finely know when you're in focused attention versus mind wandering. And then we're able to look at large-scale population data to constantly improve those algorithms and experiences. And then whenever you make a piece of technology, in order for that technology to really work, to really have consumer uptake, you have to have it paired with the human. It has to naturally fit into your human life. So we've created a device that both, fits very comfortably on the head, feels very natural to wear, as well as a user interface and an experience that gives value to your life. So it's not just a bunch of technology sitting there. It's a thing that you do every day that literally makes your life better and that you feel and you understand and you continue to engage in.
Brilliant. So let me conclude by thanking you again, Ariel, for a great keynote today and for taking the time to answer our questions.
My pleasure. Anytime.
Thanks for watching.